Hello everyone, welcome to Coders Camp. We are at 22nd day of May LeetCode challenge and the problem we are going to cover in this video is n queens. The input given here is an integer array n and that represents a n cross n chessboard. And we have to return the placement of n queens in that chessboard and in the form of list. So let's understand this problem with an example. So n queens problem or 8 queens problem is one of the famous problems among data structures when you start learning backtracking. So most of you would have started with n queens problem when you started in your college or while studying backtracking. If you're not familiar with the concept, this is the right time to learn backtracking and n queens. So let's get into the problem. So here the input given is 4, which represent a 4 cross 4 chessboard, and we have to place 4 queens in this chessboard. So now, if you are familiar with the rules of chess, you must be knowing what is the power of a queen. So if we are placing our queen in some position, then in that case, we cannot place another queen in the same row or in the same column or diagonally both the sides. This is a n cross n chessboard and we need to place n queens. So here in 4 cross 4 chessboard, if we want to place 4 queens, in that case, we have to place one queen at each row. Same way, one queen at each column. So in that case, if we strike out all the boxes, in second row, the only possible option left is this particular box. So once we place our queen at the second row, this queen will have its own positions to not place another queen. So that will be the same row, same column and diagonal cells of that particular queen. So we have striked out few cells based on the queen we placed at the second row. Same way, we striked out few cells based on the first queen we placed in the first row. So in that case, the only possible option left in the third row is the first cell. So if we are placing a queen there, so we have kept 3 queens at 3 rows, the only one queen left to be placed in our last row. So in that case, if we strike out all the columns where we have already placed queens and all the rows where we have already placed queens, the only position left in the last row is this, and we are placing our fourth queen there, and we have finished constructing our board with placing 4 queens in a 4 cross 4 chessboard. And finally, here in this problem, we have to return a result in this form where we have to place a dot in empty spaces and Q where we have placed our queens. This is one possible placement of 4 queens in a 4 cross 4 matrix, and we have to return all possible solutions for placing 4 queens in this chessboard. So let's see how are we going to approach. The problem needs all possible solution for this particular placement. So in this case, we have to explore all possible paths where and all we can place our queen. So let's start from placing our queen at the very first cell of our chessboard. So it is having at the cell 0, 0. From there, if we check what are the possibilities of placing our next queen in the next row. So once we place our queen at the first position, obviously the row, the diagonal cells and the columns cannot have another queen in them. So in that case, the two options we left here is these two cells in the next row. So by placing our queen in the first row, first column, we have two options in our second row to place our queen. That is this cell and this cell. So let's go to these two paths. So first we are placing our queen at this position and the second path goes like placing our queen at this position. So from that position, let's block the other cells where we cannot place our queen. So after placing our queens in the second row, we have the cells blocked. So consider our first path where we don't have an option to place our third queen at all in our third row. So this solution is obviously invalid as we cannot proceed further in this way. So this path terminates. So coming to this path, we have one option to place our third queen. If suppose we are placing our third queen in this position, in that case this position will strike out as queen moves diagonally and kill the other queen. So we cannot place the fourth queen here, so this path also invalid. So in this case it is not yet done. What it does, it actually backtrack to the actual position where it has placed its first queen and replace it. That is, move one position and check from here what are the possibilities we can explore. So yes, our program is going to start by placing our first queen in all possible cells in the first row, as we should have one queen at the first row. The possible options are placing at the very first cell, second cell, third cell, and the fourth cell. So we know by placing our queen at the very first cell will not give us any solution because we cannot place four queens in this chessboard. So it is not going to be a valid result. Moving on to our second path where we have kept our queen in the second place. From here there are four possible ways. That is placing our second queen at the second row in the very first position and second position and third position and fourth position. So if you observe, these four paths separately gonna follow its own paths. Like from the first queen we had four paths, so from here we again have four paths, from here again we have four paths, and further it goes like a tree. So if we placed our queen here, it is not going to be a valid solution as the diagonals cross. Same way we cannot place it in the same row. Same way we cannot place it in the this side diagonal. And possibly the fourth solution can be a valid solution if we proceed further, as these two queens cannot be killed. So first three options are going to be invalid. So our program going to stop here with the first three paths and further proceed with our fourth path by placing again four paths by having our first queen here and then here and then here and finally here, and check which are these paths are valid, and from that valid path we are further going to explore for these last row. Same way, this solution is only for placing our queen at the second cell at the top row. Once all this is done and all the results are added, it is again going to backtrack to this position and place the queen at the third position. This solution is again going to have four more paths exploring the second row, and once that is done it will have its path for the third row. Again it will backtrack and place the queen here at the fourth position in the top row, and further it has its own path. So we are simply repeating the operation of checking the queen by placing it in every next row. The one thing we have to understand here is we are going for a recursive solution, as these operations are going to be explored for all possible placement repeatedly. That is one thing. And the next thing is, once we are done with the first row, we are going to pass on the value of the second row to iterate and explore all possible solutions and create our result list with empty queue, empty strings, and finally return the result. So before getting into the code, this actually gonna work in big O of n square into n factorial, as we are going to backtrack and place queens in all possible positions. It is going to take this time complexity. So let's go to code now. So here is our code. You can find this code in my Git link given in description. So here in our main method, I have declared a board which consists of character because we are going to have dots and queues, and we are going to first fill it with all dots. And I have a result list, which is what we are going to finally return. And in between, I'm going to call my recursive function a DFS function, which is passing 0 result and the board, that is nothing but the character array. So getting into our DFS function, let me explain this part later. So here I'm going to iterate all the rows because we are going to place one row after the other. And we are going to check whether that particular cell is a valid cell. That is whether we can place the queen. If it is valid, then in that case we are going to put Q in that particular cell. If not, we are going to put the dot and call the next column. That is, if it is valid, we'll place the queen. If not, we'll check whether we can place it in the next cell in the same row. And till we get the valid thing, we will be putting dots over there. If not, finally when we get the valid place, then we are going to put a Q. So that is what this part is all about. Let's directly go to the validate section. So here in validate, how do we check whether it is a valid position or not? We should not have a queen in the same column. So this condition will check whether we have our queen in the same column. Same way, we should not have in the same row. So this is going to check if x is equal to y. X is nothing but the coordinate of that cell we have passed. So if that cell matches in any of the row, then in that case we already have a queen there, because we are checking whether it is a queue and whether it is matching the current cell. So if that is the case, then it is a false. It is not a valid cell. Same way, we are going to check the diagonals. We are not going to check the diagonals after the row, but we are going to check the diagonals before the row, towards left and right. So in that case, the absolute difference between the current cell and any cell in the diagonal matches, then in that case, that cell is the diagonal of any queen cell which is placed. So in that case, we are going to return false. If none of the conditions are satisfied, if no other queen is there to kill that particular queen, then we are going to return true. So that will be checked here, and if it is valid, then we'll place our Q. If not, we'll place our dot. So we have one more extra method. This is nothing but we are going to return the list. Here we want to return the list of lists. So here in our DFS, we are going to check if our column index is equal to board length, which is nothing but we have reached our last column in the given matrix. If we reached, in that case, we have either placed our queen or we did not place our queen, and it will be completely dot. So we are going to call our construct function, which is gonna prepare the list for us and return it to our main method. So here our construct function, nothing but it is gonna iterate through the rows, and for every row we constructed, it is gonna add to a string and add it to our result list. So this is nothing but just for a construction of our result list. So yes, this is done. Let's run and try. So yes, it is finished. Let's submit. So yes, our solution is accepted. Thanks for watching the video. Hope you liked this. If you like the video, hit like, subscribe, and let me know in comments. Thank you.